Hey folks, this is Sisir right here, and today I'm going to solve this problem. So this problem was given by me previously in my previous video, and if you haven't seen that video, then that's not a problem, right? So you can just pause the video right now and you can solve this integral. And if you have already solved this integral and you have got some conclusion or you have got some values of it, please, I request you to place it into the comment section below. And yeah, let's start the process. So first of all, you need to have some formulas to remember, and the formulas that is used to solve this problem, or the formulas that I use to solve this problem, is sine 2 theta. So you have to be clear about double angle formulas as well, which is 2 sine theta times cos theta. And another one is a little general term, but it's studied in the further calculus process, and which is the integral of 1 by x squared plus 1 dx, which is equal to the tan of inverse of x plus c, where c is a constant term and it's any integer. It is positive integer, it is negative, but it is always real. It is never complex, so it is always real. Now, tan of inverse can also be said as arc of tangent. So if I say somewhere like arc of tangent, then don't be confused. I'm speaking of tan of inverse. So let's begin the full process of solving this problem. So the process goes in this way. First of all, before you solve any integral, first expand it and simplify it. So to simplify it, you have to expand, or somewhere you can get the clue of solving the integration. So before you do that, you have to expand that. So as I have done in the numerator, you can see that I've expanded sine 2 theta as 2 sine theta times cos theta. Now again, I would like to request you to pause the video for a second, or pause the video for some moments and try this integral. Just try to simplify this stuff, and after that only play the video. And if you want to just enjoy the video, then please play the video. And if you want to really understand this concept, then please pause the video and try this out, simplifying the stuff. So I would like to give you a clue that this stuff, after simplification, it will be rather in the terms of tangent and secant terms. So if you have got that, it's good. If you haven't got that, then that's good as well. So you can learn something new, right? Now let's begin. So what I said to simplify this stuff. So to simplify this stuff, what you need to do is first of all divide both sides, or divide numerator and denominator by cos to the power 4 theta. So after you do that, you'll get the term that is located in the brackets, which is integral of 0 to pi by 4 2 tan theta times secant squared theta by tan to the power 4 theta plus 1 d theta. So in terms of theta, it's good. Now what to do, right? So the main question arises now, what to do. So there is a most famous way to solve this problem, or to solve this integration. So this integration gives you the formula. So this method gives you the answer for this problem. Now what you need to do is substitute u as tan square theta, or you can use u substitution method, right? So if you know the u substitution method, if you have learned it in the higher school level and you have used it and you are like expert in that, then you will it's like natural to know that u is equal to tan square theta. Now if you know that u is equal to tan square theta, then take its derivative, because it's the rule of u substitution. After you substitute u is equal to tan square theta, then you have to take its derivative. So for taking the derivative, you have to use the chain rule. To take the derivative of tan square theta, you need to use the chain rule, and after you use the chain rule, you'll get du by d theta is equal to 2 tan theta times sec square theta. Now rearrange this stuff and get the term, or the equation, which relates to d theta, which is equal to du by 2 tangent theta times secant square theta. Now after rearranging, you will get this stuff, And now what you do is you just substitute d theta in terms of the main equation, which is integration of 0 to pi by 4 2 tan theta times sec square theta upon tan to the power 4 theta plus 1 d theta. In that d theta, replace du by 2 tangent theta times sec square theta. Now let's see what it gives you. Is this is the further calculation that you have to make. Now let's see in the previous slide that what happened. Now in this slide, when you replace d theta as du upon 2 tan theta times secant square theta, then you can obviously look at the pattern that 2 tan theta times secant square theta gets cancelled up, and you'll only be remained with the term of du upon tan to the power 4 theta plus 1, where u is equal to tan square theta. That means u square will be equal to tan to the power 4 theta. Then you can use the basic idea of the integration, or the basic formula that you can use, that I have already presented in my second slide, I guess. And after you do that, and after you use the formulas and use the concepts and use the integration stuff, then tan of inverse of u is equal to tan of inverse of tan pi by 4, where tan pi by 4 is equal to 1, and tan 0, which is 0, and after that tan of inverse of 1 is equal to pi by 4. So basically, after solving this much and after going through the conclusion, I conclude that the answer for this integration is pi by 4. So thank you for watching, and let's hope that we meet you next time. Thank you.